In this lesson, we're going to talk about increasing and decreasing functions. Now, previously we should have understood that when you're differentiating, you're discussing the gradient. So when you differentiate a function, you get an expression for the gradient, and when you put an x value or substitute an x value into this, you can get a numerical value for the gradient, whether that be positive or negative or 0. So let's look at this function here, x squared take away 4x plus 7. And we're going to differentiate. So to differentiate this, you multiply down by the 2, subtract 1, and then differentiate this part, and that comes to negative 4. Now, looking at the graph, after 2, we can see that the graph has a positive gradient. And prior to 2, we should see that the graph has a negative gradient sloping down the way. This can be shown just from substituting values into the derivative. For example, at 2, if we substitute 2 into the derivative, at this point here, the function isn't increasing or decreasing, it's just flat. So the gradient should actually be 0 when you substitute 2 into this. So let's try that. 2 times 2 is 4, take away 4, and that comes out as 0 in our table. Substituting in 3, so it's up here, this should come out as positive. So 2 times 3 is 6, take away 4, and that's 2, which is positive. Substituting 4 in, if we're going along the x-axis at 4, again we should be in the positive side of things. This is an increasing part of the function, which is a positive gradient. So 2 times 4 is 8, take away 4 is positive 4, and so on. All these values give a positive gradient. So before 2, all the values in the x-axis before 2 should have a negative gradient because the graph is coming down, it's decreasing. So if we substitute 1 into this, you get 2 times 1, which is 2, take away 4, that's negative. 2 times 0 is 0, take away 4 is negative 4, and so on. So just by differentiating and substituting x values, and we can find out what's happening with the graph without actually drawing it. Okay, let's look at some examples you might be asked. So first example, find the interval for which the function y equals 3x squared plus 2x take away 5 is increasing. First thing we have to do is differentiate. So multiply down and reduce by 1. Derivative of 2x is 2. Now this function is increasing when the derivative is positive from the graph before. So it was increasing after 2, which gives positive answers. So that sets up an inequality. If it's increasing only when the derivative is greater than 0, that means 6x plus 2 needs to be greater than 0. So we solve that, subtract 2 from both sides, divide by 6. That would give negative 2/3, and that simplifies to negative 1/3. So to answer the question, what x values is the function increasing? That's what this really means. X is greater than negative 1/3. For all values x is greater than negative 1/3, the function is increasing. In the last example, show that the function f of x equals x cubed take away 3x squared plus 3x take away 10 is never decreasing. Well, first of all, we differentiate. So multiply down, reduce by 1. Multiply down, reduce by 1. And differentiate this to get 3. Derivative of 10 is 0. Factorise this. So you can take a common factor of 3 out. And then 3 times x squared makes 3x. 3 times 2x makes 6, and so on. And then this will become x minus 1 times x minus 1. We can write that as 3 times x minus 1 squared. Now that you've got this, we look back at the question and say, we have to show that the function is never decreasing, i.e. it can never be negative. And if you look at the squared function here, when you square a number, it always becomes positive. No matter what value you put in for x, say you put in negative 6, that would be negative 6 take away 1, which is negative 7, you would square it to become positive. So this derivative can never have a negative value because of the square term there. So we make a statement, since 3x minus 1 squared is always greater than or equal to 0, f of x is never decreasing.